Welcome back to the second tutorial on summary measures in the Excel. In this tutorial, I'm going to talk about z-score and association measures. Let's look at the definition of the z-score first. Z-score is also called the standardized value. The z-score Zi can be interpreted as a number of standard deviation that each data point of xi is from the mean x bar. Let's assume these blue dots are the actual data. The average of this data is 44. For each of this data, we can calculate a z-score in terms of the number of standard deviation that data point is away, either lower or upper than the mean. For example, if we calculate a z-score and that z-score is 1.25, that would indicate that x1, or the data point, is 1.25 standard deviation greater than the sample mean. Or if the z-score is minus 1.5, that would indicate that the data point x2 is 1.5 standard deviations less than the sample mean. So for every data point that we have, we can calculate its corresponding z-score. Z-score measures relative location, which help us determine how far a particular value is from the mean. We specify x bar as the mean of the data, s as a sample standard deviation, and z of I, or z of data point I, the z-score for xi. In order to calculate the z-score for each data point, we calculate the deviation of the data value from the mean, and we divide it by a standard deviation. This is basically the distance of each data point from the mean of the data set in terms of the number of standard deviation. Now let's look at the Excel and see how we can calculate the z-score. I'm going to call first here z-score, and this is basically the function for z that we just reviewed. Let's follow this function. It's equal to the data point xi minus the mean that we calculated here divided by the standard deviation. Here we have the standard deviation. So minus 1.22. That means that this data point is minus 1.22 times of a standard deviation away from the mean of the data set. I can repeat this for the other data points. However, first I need to fix the location for the mean and standard deviation in this function. For that, we add a $sign before, and after that the column ID for the mean F17. So I add $sign before and after F. Also fixing the standard deviation, a $sign before and after the column ID of the standard deviation cell. Click enter. Now I can repeat this for the other cells. Note that I didn't fix the B2 because as I'm repeating this function for other cells, I also want the B2 change based on the selection of the cells in below rows. So this is the z-score of each data point. Now let's talk about association measures. Let's assume that we have another variable named GPA. Covariance measures the joint variability. If covariance is positive, these two variables will move together. If it's negative, then these two variables will move in opposite direction. We know that these two variables move in the same direction. As GPA increase, there is high chance that monthly starting salary also increase. So how we calculate the covariance of these two variables? Covariance is one number. You can calculate using covar function. You give the first array, which is monthly salary, and second variable, Click Enter. You can see that the covariance of monthly salary and GPA is highly positive. It means that these two variables moving at same direction. If GPA increases, then the monthly salary also increases. Covariance tells us the direction of the relationship, but not the strength of the relationship, however. In order to find the strength of the relationship, we measure another metric named as correlation. Correlation is a standard measure from -1 to 1, and it basically shows the intensity of the relationship. So in order to calculate the correlation, you use correl function, give the first array, comma, second array, and it basically gives us the intensity of this relationship. It is still positive, and it means that there is a strong positive association between monthly starting salary and the GPA. In summary, location tells us the center, dispersion tells us the spread of the data, shape tells us how data is distributed. Are they symmetric, asymmetric, or is there any unusual values? And association, including covariance and correlation, shows the relationship between the variables. Using Excel, all these measures can be computed in seconds, helping you summarizing and interpreting real-world data. I hope this tutorial was helpful and gave you a clear understanding of how to use Excel to summarize data using measures of location, dispersion, shape, and association. Feel free to pause the video, try the formulas yourself, and reach out if you have any question.